So in this exercise, we have to show the steady state graphically in the Solow diagram. So assume for a second that the capital stock is equal to 0. If the capital stock is equal to 0, also capital per worker will be equal to 0. As a result, output per worker will also be equal to 0 because both capital and labor are necessary in order to generate any positive output level. As we increase the capital stock by 1 unit, capital per worker increases, and therefore also production per worker increases, or output per worker. As we increase capital by 1 unit again, capital per worker increases. However, the increase in output per worker is not as high as before, and this is due to the fact that there are diminishing marginal returns to capital. Okay, so therefore we have this output per worker function shape. So this here will be the output per worker function, and the savings. What are the savings? Well, in order to get the savings, we just multiply the output per worker by the savings rate. And if we do so, we get something that looks like this. This function here represents the savings or investments. Remember, savings and investments are the same because we're in a closed economy. Lastly, we have our linear function represents the depreciation of capital. So where do we have our steady state? Well, what was the steady state condition? Well, we know that in steady state, the change in capital stock equals to 0. And when is this the case? Well, this is the case whenever depreciation of capital equals to savings. And where does savings equal to the depreciation of capital? Well, savings equals to depreciation of capital wherever this green function intersects the blue function. So this here will be our steady state value of capital per worker. And the steady state value, the steady state output level per worker will be here.